Good evening to everybody that has joined today's webinar on how to use eDrilling software to boost the efficiency, consistency, and safety of your drilling operations. My name is Margie Maria Gonzalez. I am Head of Sustainability and Communications, and I will be presenting and moderating this webinar. But before we start, I just want to take a second to thank you all for joining this virtual gathering. Earlier today, in the earlier version of this webinar, and right now we have in the audience energy professionals from all over the world, and we are really looking forward to your feedback and questions. So quickly, a quick introduction to eDrilling. We are a company with more than 2 decades of experience in developing software solutions for the whole life cycle of well construction. Since 2008, our software has been deployed on close to 500 wells with great success. We have had until now 0 incidents, zero non-geological sidetracks, 20% and more in efficiency gains, and last but not least, a minimum of 17% less carbon emissions. So in today's webinar, you will learn how you can achieve this kind of results by applying our software to your drilling operations. And as we have mentioned on our virtual invitations through social media and in the mail you got, it is possible to do all of this without adding any hardware on your rig, without adding any new backup personnel, neither on location nor in an external office, and all while utilizing existing systems and equipment. So now down to the reason that gathers us here today. My colleague Joseph Nabavi, our Customer Success Manager, will guide us through setting up and navigating eDrilling software. Welcome, Joseph.
Thank you, Margie. Let me start sharing my screen. Okay, do you have my screen, Margie? Yeah, good. As Margie said, so you don't need any hardware or any other heavy deployment cost to use this software. So that's why this software is running in cloud environment. In this case, as you see here, so I'm just using a URL and then I access the software. Here, this is an internal cloud. So that's why you see Cluster 1 here and then the drilling platform and tasks. But if you deploy it in a rig, so then you see another URL which is running somewhere in the cloud. So when you use this link and add your username and password, so you will get access to the wells that you should have access to. In this case, there are different business units which has been added in the dashboard. So you have one business unit here, and then the other one here, and the third one here. So below each business unit, so you can have as many wells as you want, as you see here. And then on each well, so when you go to the each well, then you can run your tasks. By that, I mean that you can do planning, you can run real-time operations, and so on. In this case, today, we are demoing the real-time automated optimization software. Before I start showing you the results, I am going to show you how you can start a new task on your well or creating a new well or in a business unit. It's very simple, taking only 5 to 10 minutes, not more than that. Let's say if I start here, let's say this is my business unit. I have already 2 wells here. Then I will try to add the third one here. Just click on the plus button here. Just give the well a name, X, Y, Z, and then add. So then it will appear a third well on the same business unit. So before I proceed further, so okay, I can check pressure profile is here, formations is here. So this data, they are collected directly from the field data, which is available there from during planning and so on. So you don't need to add them again. When it comes to the trajectory or survey, so it can be both ways. Either you are adding again here on the task phase, or you are just retrieving from the field data. So in this case, let's just you can just use Excel or a Notepad file to just copy and paste the trajectory here. If I just click add raw, I'm just adding raw, and then I copy depth, inclination, azimuth from the trajectory, and then I just paste it. It's done, so the TVD will be calculated based on this data, and then save it. So on the well part, now I am finished. I have created a new well on the same business units. Then I'm trying to run a task on the same well. So I click on task, add a task, and then give it a name. I just call it XYZ with the small letters here, add. And then when I'm creating a task, then I need to choose BHA, geometry, and fluid. BHA, I have a lot of BHAs available already. If that's BHA, if that's drilling, I add a BHA. If that's stripping, I add a casing liner and so on. Here I have these two available now. Let's just choose this one. When I choose this one, everything pops up here, and then click save. When I go to the geometry, so you see it's for now is empty, but you have the templates for all the conductors, risers, and different casings, liner as well. So they are available. So you are just adding some rows, and then I just choose it. I choose a riser to start with, and then a conductor, 20-inch casing. Since I choose 13.5/8-inch casing to run hole, then I think this is enough for the casing, and then at last I just run or add an open hole, so to run casing. Everything else is defined in the field on the business unit, so you don't need to do that. The only thing which you need to enter here, it is the depths, because the depths change from well to well, so they are not on the field. So if I start from 0 to 300, for example, and then from 300 to 600, and then 20-inch casing from 600 to 1,200, and then I go to from open hole from 1,200 to 1,900, and then I give the diameter to an open hole, running 13.5/8-inch casing. A normal open hole is 17.5-inch. I am done here as well. Task fluid, you have all the fluids which you have in the system. It will be listed up here. So you choose the one. And then if you would like to choose another density, let's say instead of 1.5 SG, you would like to choose 149, 151, or whatever number, 170. So then you just write it. In this case, we just choose 150. That's okay. And then I'm done here in this phase as well. Then I go back to my well to launch this task. I have created a task. Then I will launch it. This task is coming here now. The last part which I do here, so I connect to the WITSML. And let's say if I have this one, and then I have this one, and then I choose just the time. This is since old logs, so they are not in real time now. I just find the one which is active and during this period of time. Let's say that's starting 2021, 2022. Should be good for this one. And now you don't see anything else. If I click here, the system automatically connects to the different curves on the WITSML. Let's say the bit depth connects to the bit depth from WITSML, well depth to the well depth, and hook load to the hook load, and so on. So they will be connected automatically. So you don't need to go and connect them manually. So once I have done this, so you see this button is getting active and green. So then you click launch the task, and then your task is running. So that's all you need to do before you can start a and not the automated optimization software to run in real time. When I launch the test, then the system is running and optimizing the parameters. If I go back to the dashboard now, so you see this is the well, but I didn't launch the test, so that's why I don't see any green or anything else. But I was finished with all the steps. The only thing which were remaining was to launching the task. And now, when you launch the task, so here and the first one, if you click on the triangle here, so it will open up this one. It will show you the bit depth, well depth, the time, and then you have 3 screens here. Drilling advisor. Drilling advisory when you are drilling, so it's useful. It's very useful to use this one, and when you are in tripping phase, it's useful to use this one. Now we are on tripping phase in this case, so I'm just choosing this one. So since the well is running in real time, so it will take a short time to launch it. So yeah, it's coming. It's not fully loaded, but they are coming soon. It just take a couple of more seconds, but this part is already loaded. Let's start with this one. So you have a roadmap here. This roadmap is both available during drilling and tripping. So when you are drilling, so it will detect the lift and slack and root of bottom. And then when you're when you are in tripping phase, so it will detect hook load during tripping in and tripping out. So in this case, we are running hole. So if you see this gray blue dots, so they are the actual hook load, which is receiving through XML from the rig side. So as you see, they are not going down directly on the roadmap, but they are going to the left and then start again from here and then goes here. The reason for that is that they have float on the string, so they are running with empty pipe and then filling the pipe, going down again, filling the pipe again. But this one's the light dots, which is shows a direct line here downward. That is compensating automatically the buoyancy effect due to empty pipe, and that's showing the actual friction. So this plot is available during real time and showing you all the time your well friction both inside the casing and in open hole. And on the left side, so you have your operational window. So on the left side, so you have pore pressure and collapse pressure. On the right hand side, so you have the fracture pressure. So in the middle, the dark red line is the ESD on the well. On the light red line is the ECD or surge pressure on the well. So you have always this in front of you. It's changing according to if you are drilling. So it's related to that. If you are tripping, it's showing the trip, your surge or swap pressure. And then in the gauge, so you have a gauge here. So it's showing this yellow area means that you are not allowed to increase your speed in this area. So until this green triangle, so this is your operational window from 0 to here in this side. So in this side, because since we are running hole, so it's this side which is active now. So from 0 to here is your safe window to run hole right now. So it's changing. If you are up in the well, so your surge will be less on the casing, then maybe this blue dot is somewhere here. But now we are on the open hole, so it's getting very small. But the unit is meters per second, so it's still very, very fast, this area. As you see on the bottom, there is a recommended speed, 0.22 meters per second. This is your optimal speed. So on the software suggests that you can run with this speed without creating any losses or facing any other downhole issues. And this is the actual speed. So you are far below your operational window. Here in the top, so again, so this green line, this is the actual speed. So when this up peaks, they are when you are doing connection and go upward. But this is when you run hole, this is the small steps showing below. And then the yellow line shows you your safe operational boundary. This is the optimized value. And here you have some other values, casing ACD or source pressure at bottom, and ACD source pressure at casing shoe. This is during tripping. In addition to that, the software is connected to a downhole 3D model, which is dynamic and updating during real time. This is the 3D. Let me make it full screen. This is a downhole 3D. You can add, let's zoom a bit. So this is now we are running with a 4.5-inch liner, so you don't see any BHA elements here. It's just a pipe that you are running hole. But when you are running hole, so the 3D included the down BHA models as well, that you can see where is my stabilizer now, where is my reamer, and another where is my mud motor, and so on. Any type of the tubular you would like, you will see it here, and you can follow exactly that one. And then you have control all the time. Where is this element, which is where risk up. And then in addition to that, so you can add all your risk in the well along the well bore, and that is in front of you in the real time. So as you are tripping in or tripping out, you see in front of you or upward, downward, and you see, okay, in this step, I face this risk. I need to run hole a bit carefully through this area. Let's say that you have some shale formations, then you would like to be a bit more careful. And then you run slowly, or you have some other procedure. So you don't need to check other documents. Where is this steps? So you have everything in front of you. I had another scenario, which is showing that drilling. Let me show you that screen as well. This is another well, which is during drilling. So this is the drilling window. The drilling window shows your optimized flow rate, your optimized rotational speed, and your optimized ROP. So in this case, right now, so you see a green box here with a number, and then you have which shows the flow in value, and then you have a green box here with a rotational speed value inside, and a smiley face on the right hand side. Means that you are up to the optimized parameters in this case. But as you see on the ROP is showing between almost red, means that you are very low on the ROP right now, and then you can increase until this number. So you can increase your ROP by this number. So you can add 3.6 plus 35. It's around 38 meters per hour. You can drill the section right now with the condition that you have in the hole. Here on the right down corner, so you have your geometry here, and the geometry. This is start if you choose the casing shoe. It's just showing you from the casing shoe and down to the bit or to the well depth. So and then if you choose the well, then it's showing you the whole geometry. If I choose the casing shoe, you see some yellow triangles here. They are the risk that the system automatically generated at this steps, at this step, this step, this step, at this step. There were some downhole risks which has been detected automatically by the software. and then it has generated an alert to the user. Okay, at this step, now you are facing this risk. And then the risk includes some suggestions as well. Okay, the risk on the well is now this one. You need to increase the flow, decrease the flow, pick or bottom, or anything. So as you see, there are some examples of the warnings which is created automatically by the software. So potential pack off, cutting speed, and so on. Extensive off bottom work. So it means that you done a lot of bottom work. You circulating and rotating off bottom without doing anything else. So those kind of risks, they are generated automatically by the system. That warning you, okay, you need to be careful now. And the depths are coming here. This is from this area. And from this area and down, you see you don't see any other risks. So are all good to go. I think I'm running out of time. Margie, so I will stop here.
Okay.
So I think we can go for questions if anyone has any questions.
Yeah, thank you, Yusuf. You said it. If anybody has any questions, you can just click on the icon with the question mark. We have one question. The ECD shown in this web and search graph is calculated. That's the first one. Or I'm sorry, the last part of the question. Or is a data taken from APWD?
Since that the one which I show you, it was during tripping. So during tripping, you don't have any real-time ECD. So that was modeled ECD.
Okay, and large question / comment. Another point, I guess you can change the units to see the speed in the bits per minute, right?
Yeah, of course, you can have it per minute, or on the oil fill unit as well. So you can do those things are very simple. So if I just show you here, so it's not showing that one, but that's the same concept. Since I have a unit system here, I have SI unit, oil fill, metric, and then I can add another unit, just call it mixed unit. And I just change the numbers whatever I want. So then I can use this unit. Something is showing in feeds, other was showing on. We are very flexible on using different type of units. Just an example here.
Okay, we have the second question. How the optimum parameters are determined?
The optimum parameters, yes, that's a good question. Let's say that you are drilling at 2,000 meters now, and then you are doing connection. During connection, the system checks the state of the well right now. So to start with, so when I created a task at the beginning, it means I created a digital twin of the well in the system, which is running in real time. And then when you run in that digital twin during real time, so it saving the state of the well during each connection. When you start doing connection, it saves the state of the well. Okay, now I have so much cuttings. This is the temperature. This is my boundaries, and so on. And then run a lot of simulations. During tripping, it runs 12 different simulations, and then pick the best one and add it as an advice to the user. During drilling, it does 64 different simulations, and then pick up the best option for the ROP, for the flow rate, and RPM. The best option among all those three, combined best option of all those three, and then suggest the values to the user. Those simulations, I repeat again, those simulations will happen during each connection because the well condition always changing. you are drilling a stan or run a hole with a stan and then doing a connection. During that period, the system running a lot of simulations, taking the condition of the well right now, running a lot of simulation, and suggest you the speed for the next step.
Okay, we have one more. Hi, did the log data used is time or depth based?
It is time-based data.
And 1 second. Does this include reaming or pumping in and out of hole?
Yes, both reaming out, reaming in, enlarging the hole, tripping in with the liner, casing, screens, cementing, all those operations are done by the software.
Okay, and what it seems to be the last one. How do you see ahead of the bit, as you said?
Let's say your bit is here. If I show you that, I believe the question was most related to the 3D ahead of the bit. So let's explain both them. If you think about the 3D, then your bit is here. You see in front of you what is your risk in front of you if you run in hole or drilling. So you see, I will face a tight spot here at this area. So then you are running hole. So you know what is your risk in the head. If you pull out of hole, so you see these areas behind you. This is how you can use the 3D and use in front of you during tripping and drilling on the driller's chair without using other trip risk sheet and those kind of things. It's replacing all those kind of things, and this is dynamic and is always in front of you. You need just a PC screen to log in. And then when it comes to the advisory part, how we can look ahead of the bit. So you are taking the current condition of the well with the amount of cuttings that now you have in the well. How is your hole cleaning right now, flow rate, RPM, and ROP, and based on that, so you are projecting, running a lot of simulations. What is my best option to drill the next system? That is how it is advising you the future value.
Yes, we got 3 more. How do you calibrate the simulations to guarantee the most realistic results?
There are 2 things. The first thing that we are using the input data is important. Let's say that you have correct geometry, you have correct trajectory, and so on. That those input parameters are correct. In addition, the system at the beginning of when you start your simulation, if you have some deviations, the system automatically auto-calibrate itself to be as accurate as possible to the actual values. Let's say during drilling, the modeled SPP is a bit lower or a bit higher, and then the system run for a 6 hours period. If you see everything is stable, and then after that it start calibrating to the actual value. The same goes with ECD. And then when it has been calibrated, then it's just follow the same trend all the time. Any deviations after that will show you the risk in the well, show you something is not correct, showing that something is not as it should be. The other part, which is very important, rheology is affecting a lot, of course, during drilling. It's changing all the time. We have 2 options. You can insert the rheology manually. That's one option. That's not the best option. But the other option is that you have some sensors on the rig side, which measuring the rheology. And then the system takes the real-time rheology all the time and using that for the simulation.
Okay, we are out of time. There's a couple more questions, 3 more, but as we do in the other seminars, we personally send the questions, written questions to your mail. So I think that's what we're going to do, if that's okay for everybody. Yeah, that's what we will do. So once again, thank you so much for joining. Sorry. We hope you enjoyed this webinar, and you will be receiving the link to the presentation together with our appreciation and a link to YouTube and where we have all the webinars that we have had until now. And as I said, we will be answering the remaining questions. So thank you so much for attending, and see you next time. Have a great evening, everybody.
Yeah. Thank you very much. Bye-bye.